if we start with section 8.1, we're looking at functions. And the reason, why am I still on that? Oh, I haven't switched over. So if we're looking at functions, because linear equations, all linear equations are functions. Okay. A function is anything where the x goes to only one y. You can't have a single x that's matched up with more than one y. Now remember, you can have a y that comes from two different x values. That's allowed. You just can't have one x value matched with more than one y. So this is still a function, okay? And this is a function. The only thing that's not a function is if you have multiple x, if you have one x going to multiple y's. Now, there were a few ways that we learned to find whether or not something was a function, okay? The first way that you learned is the mapping diagram, which is you put all of your x's in one little oval, all of your y's in the other, and then you just draw the line. So if I had like 3, 2 as one of my points, and 2, -4, and 1, 2, then I would have a mapping diagram that looks like this. Is this a function? Yes, because every x is going to just one y. Remember, a y can come from two different x's, but x can only go to one y. Okay? So, that's one way you could discover whether or not it's a function. If you have a graph, the easiest way to discover if something's a function is what? Thomas? Right, we have something called the vertical line test. If you have the vertical line test, it says, okay, if I draw a vertical line and I put it going through any point, it's only going to go through one point at a time, right? If I take this line, oops, and I move it to where it's going through this point here, still only going through just that one point, right? So as long as it only goes through one point, then it passes the vertical line test, which means it is a function. If at any point you have 2 points that would be on the same line, then that tells us it's not a function. Now the reason why, because this, let's say this is, now this is obviously just a sketch, but let's say this is the x value 2 and this is the y value -2 and the y value -4. Well, so I have 2 -2 and I have 2 -4, which means the x value 2 goes to -2 and it also pairs with -4, right? Anytime you have 2 points on the same vertical line, then that means you have a single x value matched with more than one y value. So that's why the vertical line test works. All right. If you have a set of ordered pairs, you can also just look for, if you have the x value repeated, if you have more than one x value, then that means it's most likely partnered with more than one y value, which means it's not a function. So that's all we had to do in section 8.1. Definitely one of the easiest. Excuse me, there's actually one other thing. If I have function notation, f of x equals 3x plus 2. All this means is my y value is equal to 3 times the x value plus 2. And then you can plug in x values. Like if I said, okay, what if x is 2? Then I have f of 2 is equal to 3 times 2 plus 2. And then you can work out what f of 2 is. So that'd be 6 plus 2. So f of 2 is 8. All that means is the y value, f of 2 is the y value when x is 2. So you need to be familiar with function notation. So that's all there is in section 8.1. Now, section 8.2, we're getting into sequences. And really, after having done some of the stuff later in the chapter, sequences should come a little bit easier than they did to begin with. Sequences is, if I have 9, what do you want me to do? Add something, subtract something. What's our pattern going to be? 12. All right, so we're adding 3 each time. So 15, 18, dot, 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 dot. All right, so there's my sequence. This sequence shows a constant rate of change, doesn't it? If I'm increasing by 3 each time, I have a constant rate of change. It's increasing by 3, which means if I were to graph it, this would have a slope of 3, right? We learned in that section to put it into a table. So this would be the first value, second value, third value, fourth value, and so on. Which means my change in x is always going to be 1, right? From 1 to 2, from 2 to 3, from 3 to 4. It's my x values are changing by 1. My y values are changing by 3. So if I did rise over run, my slope is 3, right? So this is all this is. Sequences is still rate of change. If we have a sequence, if it has a pattern, that means it has a constant rate of change. In other words, it has a slope, a constant slope. The slope being, since it's by every one number that it goes up by 3, that means its slope is 3, which means our equation is going to look like y equals 3x, right? But then, Amber, put the book away. But then, we need to know what we need to do to 3x in order to get that. Because obviously, 3 times 1 is not 9. And 3 times 2 is not 12. And 3 times 3 is not 15. Well, this is just the exact same thing we're doing in this last section. This is my slope-intercept form of a line is y equals mx plus b. And I'm saying, okay, my m I know is 3. That's my constant rate of change. And I can use any x and y. I can use 1 and 9, or I could use 2 and 12, or 3 and 15, and I can plug those in. If y is 9, my slope is 3, x is 1, plus b, I have to figure out what else I need to do besides multiplying by 3. So 9 equals 3 plus b, and then subtract 3. And so my b value would be 6. So my equation is y equals 3x plus 6. Now, we didn't do it in terms of mx plus b when we learned it in sequences because we hadn't learned slope-intercept form, but it's the exact same process. All we did in that section was we said, okay, I know that I'm adding 3 each time, which means I have a repeated addition, which is multiplication. So my y value is going to be 3 times my x value. But 1 times 3 doesn't equal 9. 1 times 3 equals 3. So that means I need to add 6 more to get 9. Or if I pick the second one, 2 times 3 is 6, which isn't 12. So I need to add 6 more to get 12. So it's the exact same thing. This is the thing about this unit. It may seem like, oh, we covered a lot of material, but really most of the material kind of all boils down to being the same thing. It's all kind of the same, just different ways of looking at it. All right, so you need to be able to find a sequence, and you need to be able to find a number term in the sequence. If I want the 12th term in the sequence, all I have to do is, after I've got my equation, replace x with 12, so I'd get y equals 3 times 12 plus 6. 3 times 12 is 36, plus 6 is 42. So the 12th number in this sequence would be 42, right? All right, so that's all we had to do in 8.2. Now, then we move into 8.3. This is where we start looking at t-tables, the main things we learned in this section, 8.3 was the one that we spent multiple days on, putting equations into y equals form, or putting them into standard form. So that's what you need to know from this. You need to know how to put something into standard form. Remember, standard form is ax plus bx equals c. And remember, a has to be, what does a have to be? If I'm putting an equation in standard form,
Positive.
thank you. A has to be a positive number. So if I want to put this in standard form, then I just have to have A be a positive value. And then the other way that we can put it into y equals mx plus b, we can put it in that form. So those are the two ways that you can put it. If you put it in this way, that's more helpful if we are looking for the x and y intercepts, because if we want to find the x-intercept, that means, oops, I put an x there, that's supposed to be a y. That's my bad. Ax plus by equals c. So if we're plugging into this, if I want to find my x-intercept, we just basically let this term go away. Because if I'm looking for my x-intercept, y is 0, so that doesn't exist. So I have a times x equals c, and then I just divide by a and find out what x is. Okay? If I'm looking for my y-intercept, then this term goes away because x is 0, and then I have by equals c. Divide by b, and you get whatever y is. So that one is more useful if we're looking for x and y intercepts. This one is obviously more useful if we are using a t-table, or hopefully you guys like as much as I do, slope-intercept form. I think that's definitely the easiest way to graph once you get the hang of it, because it tells you one point and tells you basically directions on how to get to the next point. So you need to know how to find either of those forms. You also need to be able to make a t-table. Even if you don't like using a t-table as much now because you like slope-intercept form, like I really don't like doing t-tables because I think they're annoying, and I'd much rather use slope-intercept form. But you need to know how to do them. Remember, within table, all it is if I have y equals 3x plus 2, you pick x values. Like I could pick x is 0 because that's my favorite, because that makes this thing go away. So I get y equals 2. I can let x be 1. I can let x be negative 1. I want to pick small values so I don't end up with a big giant graph. If I let x be 1, then I have 3 times 1 plus 2. So that's 3 plus 2, which is 5. If I let x be negative 1, then I have 3 times negative 1, which is negative 3 plus 2 is negative 1. So always on a t-table, always graph at least 3 points. That way if you mess one up, you'll figure it out because they won't make a straight line. Let's see. 8.4, 8.5, 8.6 are all rate of change or slope. Here are the things you need to know about slope. Slope is the same thing as rate of change. You need to know that slope is rise over run, which also translates to the difference in the y values divided by the difference in the x values. To be going over stuff for your test tomorrow, a lot of you are not taking notes. Probably not the good plan. You should probably be writing stuff down. All right, so rise over run, which means change in the y over change in x. You need to know this because if I give it to you in a graph, it's easiest to just count your rise and your run. All right, start at one point, count how many units down you go, count how many units to the right or left you go. Okay, this way is the best way if you are given 2 points, because you don't really want to have to graph it to be able to count. So you need to know both of those. Yes.
For graphing, if you have a whole number, don't you do 1, like the whole number over 1?
Yes, yes. Yeah, if your slope is a whole number and you're needing to graph it, a slope of 3 is the same thing as 3 over 1. So, and also remember, a positive slope is the same thing as a negative rise over a negative run. And a negative slope can mean a rise of -2 and a run of 3, or it could be a rise of +2 and a run of -3. If it's negative, either the top or the bottom is negative. It doesn't matter which one, because going up and to the right is the same thing as going down and to the left. Either way, you're getting to the same points, right? So, same thing is true down and to the left and up and to the right also get us to the same point. So, positive slope is the same as a negative divided by negative. Negative slope is a negative divided by positive, or positive divided by negative. So you need to know that about slope. The only other thing that was a little bit different is 8.5 also talks about direct variation. Direct variation can also be called proportional. So you need to know both of those terms. A lot of the things in this unit that mess people up are vocabulary. So you need to know direct variation is this, if an equation is a direct variation equation, it's proportional. All that means is that your y value is equal to some constant times your x value. No y equals mx plus b, it is just y equals mx, okay? The slope of your line times your x gives you your y value. You can check it on a graph. Easiest way to check for direct variation on a graph, it has to go through the origin. Because if I take my x value being 0 and multiply anything times it, it's going to give me 0. So if my x value is 0 on a direct variation equation, my y value is also 0. Every direct variation equation goes through the origin. If I want to check it from a table, then all I have to do is look at the relationship. From 3 to 12, I am multiplying by 4. From 7 to 28, I am multiplying by 4. Or you can do it backwards. You can say 12 divided by 3 is 4. 28 divided by 7 is 4. And if you take your y value and divide it by your x, if you don't get the same thing for every y divided by x, then that means you're multiplying your x value by different things to get your y value. Or you're multiplying by the same thing but then adding something else. So, direct variation, this is what it looks like as an equation. This is what it looks like as a graph. Now, obviously, it can't have a negative slope or a positive slope, but it has to go through the origin. And as a table, what you'll see is that every x value is going to be multiplied by the same thing to reach every single y value. All right, so that's all there is from 8.4, 8.5, and 8.6. Except for the unusual slopes. Remember, you need to know the difference between a zero slope and an undefined slope. If I have a graph what kind of slope does this line have? All right, that's a zero slope, okay? If you think of it as a slope as a hillside, that hill has no slope at all, right? It's perfectly flat. So this is a zero slope. Whereas if I have this line right here, well, it came out a little crooked, assuming it's straight up and down. This one's going to be undefined. So you need to be able to recognize from a graph zero slope versus undefined slope. You also need to be able to pick it out from an equation. An undefined slope, this is x equals 3. If I have x equals something, it's going to be an undefined slope because that means the x value is the same throughout. And if the x value is the same, I'm always 3 units right, then that's going to give me a vertical line that gives me an undefined slope. It also gives me an undefined slope because if you think slope is rise over run, what's the run of this line? How far to the left or right am I going between points? Pick 2 points. From this point to this point. What's my run? 0, right? I'm not running. I'm just going straight up or down. And so it doesn't matter what the rise is. The rise is 7 between 2 points. The rise is 2. It doesn't matter. Your run's always going to be 0. And something divided by 0 is undefined. So you need to know that if you have 2 points and you're finding the rise over run by doing y2 minus y1 over x2 minus x1. If your x2 minus x1 gives us 0, then you have an undefined slope. Now, if it has a 0 slope, the equation would look like y equals something, because all of these points are 1, 2 units up. That's what they have in common, right? They have different x values. This is x is negative 1, 2, 3, 4, 5, 6, 7, negative 7x, right? Here x is negative 2, here x is 1, here x is 4. But y for every single point on that line is positive 2, right? So this is the equation y equals 2. If you have y equals 2, that has a 0 slope. You need to know that y equals lines are parallel to the x-axis. X equal lines are parallel to the y-axis, right? So it's kind of backwards of what you would think. If the equation is x equals something, it runs up and down like the y-axis. If the line is y equals something, it runs left to right like the x-axis does. And same thing here, if we think of slope as rise over run, what's our rise for this one? How much does that line rise from, say, this point to this point?
0.
Right, 0. This one has a rise of 0. The run could be anything depending on which 2 points you look at, say 12. But it doesn't really matter because 0 divided by 12 is 0. Remember, 0 can be divided by something. You can't divide something by 0. All right. Remember to watch the video tonight to look at any ones that you missed on the practice test. Test is tomorrow. Make sure you study, come in prepared. There is going to be a bonus question. I have an IXL section that goes over some basics of how to do the bonus. So if you want a chance at getting the bonus right, you can look at some of those IXL questions tonight.